Alright, in this video here I'm going to do some examples of the transformations of sine and cosine graphs. Now if you didn't watch the other video that I did where I explained the rules for the transformations, I would advise you to watch that video first before you see this one, so you understand what those rules are, because in this one I'm just going to use those rules to graph these functions. Alright, so the function we're going to graph here, y equals 2 times cosine of theta plus 1. Alright, and again, theta is my variable, it's the Greek letter theta. Sometimes with trig functions we use that instead of an x for our variable. It's just one of those things, you just have to get used to it. Right? So 2 times cosine of theta plus 1. So here's all the things I need to find: the amplitude, the period, horizontal and vertical shifts, and then after I graph the function I can talk about the domain and the range of the function. Alright, so first off, amplitude. Remember, amplitude is the height of the wave, how tall it gets. Alright, so that's determined by a number multiplying my parent function. Well, here I have a 2 multiplying my cosine function, which means my amplitude is 2. Right, remember, the amplitude is the absolute value of this number here. Right, so if I just have 2 forget this plus 1 for a second, for 2 cosine theta, here's my cosine graph of my parent function. Instead of going between positive 1 and negative 1, if there's a 2 in front, it goes between positive 2 and negative 2, right? It stretches it out by a factor of 2, similar to those rules we talked about for transformations of graphs of other types of functions, previously. All right, so my amplitude is 2. My period, right? The normal period for the sine and cosine functions is 2 pi. Right? Between 0 and 2 pi, it does one full cycle before it starts to repeat itself. Well, with our transformations, what affects the period is if there's a number multiplying the variable. Well, here it's cosine of theta. There's no number inside that parent function multiplying the theta, which means our period is not going to get changed here. Right? So my period is still going to be 2 pi. Right? The only time that changes is if I had like cosine of 5 theta or cosine of 3 theta. Right? A number multiplying that variable there, that's going to affect my period. If there's no number there, the period is just the standard 2 pi for the typical cosine function. All right, horizontal shift. Horizontal shift is when I have a number inside the parent function being added or subtracted to my variable, which I don't have here. Right? It might be confusing to say, well, there's a theta plus 1, so there is something being added. Right? But in order for that to be considered inside the parent function, it would have to be like this: cosine parentheses theta plus 1. Right? This theta plus 1 is going to give me a horizontal shift of -1 because it's inside that parent function, inside the parentheses with the theta. Right? What we have here though is cosine of theta plus 1. Right? So the horizontal shift is going to be 0. The plus 1 that's outside of the parent function, right? It's not inside the parentheses there. It's going to be a vertical shift of plus 1. Right? So it's going to shift my entire graph up 1 unit with no horizontal shift at all. Right? So again, paying attention to the notation. If the theta plus 1 is in parentheses, that's going to give me a horizontal shift. If it's not, then it's a vertical shift, because that plus 1 is separate now from the cosine function. All right, so it's little things you have to be aware of. All right, so there's all the information I need to sketch this graph. Let's go ahead and sketch this graph. Okay, we can make this work. So my vertical shift is plus 1, and I have an amplitude of 2. All right, so let me go up here. This is going to be 3. This is going to be -2 here. All right, so my vertical shift is plus 1. So what that's going to do is it's going to take this entire graph and move it up 1 unit. So normally for the cosine function, the mean value, or that middle value that we have, is 0. It's on the x-axis. But when I have a vertical shift, it's going to basically take that x-axis and move it up 1 unit in this case. All right, so what I'm going to do here, and you don't have to do this when you're graphing these functions, but I'm going to draw that horizontal dotted line at y equals 1. That represents my vertical shift. Right? Instead of the x-axis being that middle value of my graph, now my middle value is going to be y equals 1. All right, so that dotted line there just lets me know that I'm shifting my graph up 1 unit, and for me it helps me to graph the function. All right, so my vertical shift is going to take me up 1. I don't have a horizontal shift, so when I do my starting point, I don't have to move to the left or to the right at all. My period is going to be 2 pi. All right, so since I'm not shifting to the left or right, what I'm going to do is put a mark down here that says 2 pi, and then I'm going to cut that in half, and then I'm going to cut each of those in half. All right, that's going to give me basically my points that I need, my guideposts to plot the points to graph this function. All right, so whatever your period is, 2 pi, from your starting point add that, so 0 plus 2 pi takes me to 2 pi, and then cut that into 4 equal pieces, right? And that gives us, where we're going to put all our points, right? So I don't have a horizontal shift. I'm not moving left or right. I have a period of 2 pi. I have that taken care of. My amplitude is 2, right? So the cosine function, and pay attention, right? The cosine and the sine functions, all these rules for the shifts and the amplitude and period are the same, but the graphs themselves start at different points. So if I'm going to graph the cosine function, remember the cosine function at the beginning of its period starts at the maximum point, right? Whereas the sine function at the beginning of its period starts at that middle value, right? So since this is a cosine function, at 0 here, at the beginning of this first period, I have to start at the maximum point, right? Which is, it's an amplitude of 2. So from this vertical shift up 1, I have to go 2 more above that, right? So I shifted it up 1, right? That's that dotted line at y equals 1. And then the amplitude of 2 means that the wave has a height of 2 above that line that I drew. That's why I draw that line there, because that kind of gives me my bearings when I'm graphing this. Like that's my frame of reference, right? Everything is in terms of that dotted line, that mean value, we call it, right? That middle point of my graph. All right, so from that middle point, cosine starts at the maximum with an amplitude of 2. It takes me up 2. And then I use my guidepost. At the next guidepost, it comes back to the middle line, right? From the maximum to the middle, to the bottom, to the middle, to the maximum again. And that's 1 full period. That's why I took this and cut it into those 4 pieces. Then I just go top, middle, bottom, middle, top to graph my cosine function. So the top, the middle, the bottom now is going to be 2 below that dotted line, which is going to take me down to -1. Remember the amplitude, I go that high above and that high below that middle line. So I take 2 above that middle line for the high point, I go 2 below it for the lowest point, which in this case would be a y equals -1. And then I'm back to the middle, which is not the x-axis, but that dotted line that I drew. And then at 2 pi, at the end of my period, I'm back up to the maximum point. And there's 1 period of the graph of y equals 2 cosine theta plus 1. And then I can go ahead and do that again. Here's -2 pi. Half of that is -pi. Cut those in half, and I go the middle, and then all the way down here, and then back to the middle, and then back up to the top. And there's another period on that side, and I can do the same thing on this side. I'm not going to bother marking the points just to save some time. But depending on the instructions for your problem, if it just says to graph 1 period, then that first thing I did there between 0 and 2 pi, that would be all you need to do. But if it says to graph the complete function, you might want to draw more than just 1 period. Or some problems say graph 2 full periods of the function. So depending on what it asks you to do, you might have to do more or less at that point. All right, so that's our graph. We had to do the vertical shift up 1, so that takes our middle value from the x-axis and moves it up to y equals 1. That's why I drew that dotted line there. And then my amplitude of 2 means my high point is 2 above that line and my low point is 2 below. And then, again, my period wasn't affected and my horizontal shift, there was no horizontal shift there. And so I just went from 0 to 2 pi, right? That's 1 full period. Cut that into 4 pieces, and then you just do, for cosine, the top, the middle, the bottom, the middle, the top, right? You mark all those points, and then you've got your graph. And some people do this, like they do the vertical shift and draw that line, and then for the amplitude they say, okay, so I go 2 above that line, and let me draw another dotted line there. That's going to be my highest points, and then I go 2 below that line, and I actually messed that up over here. All right, this should have been at -1. I don't know if you all noticed that. But I draw another dotted line 2 below that, and then my whole graph has to go back and forth between those dotted lines. So if you find that helpful, you might want to do that too. Do your vertical shift up or down, and then add and subtract your amplitude. Go 2 above and 2 below, and do more dotted lines. And then your entire graph is going to bounce back and forth between those dotted lines, with that other one being in the middle. All right, so that also might be helpful for a problem like this. All right, so there's one example, and I'm going to pause the recording here, erase this one, and put up one more that I'll have to go through a lot quicker to get through it before we run out of time. Realized as I was putting up this next problem that I forgot to mention the domain and range of that last one, but if you remember what that graph looked like, the domain was all real numbers from -infinity to +infinity, because that wave is going to stretch out in both directions forever. And the range was from the lowest point we hit, which was, I think, y equals -1, to the highest point, which was y equals 3. So like those 2 dotted lines that I drew on the top and the bottom, those kind of set off your range for you for that function. So I just wanted to briefly mention that because I totally forgot to do it before I erased that last problem. I'm going to pause this again and finish putting up this next example. All for this example, which we'll try to go through kind of quick, we have y equals -2 times sine of theta plus pi minus 1, right? So we have several different transformations here, and I already put up some of the information just to kind of save us some time here. So the amplitude is 2, right? The amplitude is that the absolute value of that number that's in front of the sine. So the absolute value of -2 is +2, but we can't just ignore that negative. That negative out front means we're actually flipping over the graph, right? If you recall from the rules of transformations, the negative in front is the reflection in the x-axis. It flips the graph in that vertical direction. So that's what's going to happen here. So instead of the graph starting in the middle and going upward, this one with that negative in front is going to start in the middle and go downward, right? This whole graph here is going to get flipped over. All right, the period is going to be 2 pi. There's no number here multiplying my theta, multiplying my variable. Remember, the period is 2 pi divided by whatever number is multiplying there. There's nothing there, so it's just going to be 2 pi, right? The normal period for the sine function. The horizontal shift is going to be -pi, right? That's the number added or subtracted to the variable inside the function. And remember, it's the opposite sign. So this plus pi means my horizontal shift is actually going to be -pi. The vertical shift is the -1, right? The number that here is subtracted outside of the parent function. That gives me the vertical shift. All right, so let's put it all together and draw this graph. Vertical shift, and maybe I should mention, to see an example where the period is affected, because neither of the ones we're doing on this video, the period doesn't get changed. But in the last video that I did where I explained all those rules and I did one example, in that example, we did have to change the period. So you might want to check out that video to see what happens when the period becomes something different. All right, my vertical shift is -1. So my middle line of my graph, instead of being along the x-axis like it usually is going to be down 1 unit, right? And from there, I'm going to have an amplitude of 2. So I go 2 above that line. I'm going to actually draw another vertical line here like I talked about in that last problem. And then 2 below that line is going to give me my minimum value down here at -3. All right, so by doing that, we see that the range of this function is going to be from -3 up to 1. All right, that gives me my range of my function. All right, and the domain for any sine and cosine function, the domain is going to be all real numbers, -infinity to +infinity. All right, so I've got all my vertical stuff set up, my shift and my amplitude, which is the stretching it out. Let's see. I have a horizontal shift of -pi. So normally my graph for the sine function starts at the origin, right, which this time is being moved down 1, but it's also being moved to the left pi units. So let me go over here and put in the point for -pi, and then over here it's going to be +pi. So this graph is going to start right there, right? Left -pi, down 1. Right, my horizontal shift and my vertical shift, that's like the origin of this graph, right? It's moved to the left pi and then down 1, right? So that gives me my starting point for the first period of this graph that I'm going to draw, right? And now the period of the graph is 2 pi, right? So to figure out where that period is going to end, I take this point, this -pi, and I add the period to it, right? So if I do -pi plus 2 pi, that's going to equal +pi. Right, and I already put that point up there because I knew it was going to be. But that's why I put that point over there at +pi. That's going to be the end of my first period. Right, I shift left pi, so it's left to -pi. Add the period 2 pi to that. It's going to take me over here to pi. So my period is going to have to end right there at pi. Right, now I just have to fill in the points in between. All right, so remember, for the sine function, usually we start in the middle and then we go up to the maximum point. But in this case, since we have that flip, we go the other way. We start in the middle. Oh, what I need to do is I need to split this into 4 pieces. So in between those two, halfway would be at 0, and then I split each of those in half, and that's going to give me where I set up my other points, right? So from -pi, since I'm flipping over, I have to go down to the minimum point. Again, because of that negative there, I'm flipping the graph over. So instead of starting upward, I start downward. And then in the middle, back here, and then up to the high point, and then back to the middle. And then there's one period of the graph of -2 sine of theta plus pi minus 1. Right? So, and then to do the other periods, you would just kind of set it up again and put the points and then connect them in both directions. To save time, I'm not going to draw those. Just one period is enough, and then you just kind of repeat that pattern over and over again. You get the rest of it. Right? So when you're graphing these transformations of sine and cosine functions, it's something that students tend to struggle with a little bit. You first need to know what the graphs of the original sine and cosine functions look like, so that's important. You need to know the rules for all the shifting and stretching and all that stuff. And then you also have to be able to put all of them together. And hopefully in the examples that I've done, I've explained that well enough that you understand how I got to all these points and where I did them. I hope that helps.